Hey, good morning. I'm hoping that today is going to go really quick because you've been doing graphing linear lines for a long time now. And so we're just going to refresh our memory about it and make sure that we can write domains and ranges correctly because they're going to give us the domains today. And then sometimes we're going to use those domains to graph. And then at the end here, we're going to use those domains without graphing to find the range instead of just plugging the numbers in. So I think you're going to find today goes pretty quick. It's a lot of mental math, I hope. Okay, so we have these tables all the time. First of all, this is a linear line, and you should probably have a ruler by now because that's what we're going to use rulers for a couple weeks now. Probably for about a month here, so make sure you get a ruler. This is a linear line because I see it's in the y equals mx plus b form. My slope is right there, and there's my y-intercept. Okay, so I know this is going to be a linear line. I also like to predict which way my line's going to go because I look at the slope right here. And the slope is positive. In my head, I'm thinking when I'm done graphing this guy, my line better be going in an upwards fashion as I read from left to right. Okay. A lot of times they give us numbers or we pick numbers. We'll start picking them here in a little while. But we try to pick a couple negatives. We try to use 0 and a couple positives so that we can do mental math. Because that's our hope, is that we don't have to keep plugging these numbers into calculators. Now you have to do order of operation though. So when I plug in that -1, I need to do this multiplication first. So -1 times 2 is a -2, and a -2 minus 3 is a -5. Now this is really a coordinate over here. I'm going to put the parentheses, but we got to kind of think of it as a coordinate. That I'm putting in this x, now I'm going to put in 0. 2 times 0 is 0, minus 3 is -3. Then I want to put in 2. 2 times 2 is 4, minus 3 is 1. 4 times 2 is 8. 8 take away 3 is 5. So it is our hope that we use small numbers. That's easy enough to do mental math. Now when we come over here and we start graphing this guy, that means go to the left 1, down 5. 1, 2, 3, 4, 5. Don't make your dots real big because now we're getting tinier graph paper. Today's pretty good size still, but we'll get smaller and smaller graph paper, okay? 0, 1, 2, 3. That means go to the right 2, go up 1. And because I know it's a linear line, I have to sneeze. Sorry about that. All these dots should fall into a line. So if for some reason I have a dot like, I don't know, let's say right there, and I see, hey, wait a minute, that's not right. So I probably messed up on my math over here. You'll see it probably happens for me a couple times a day. I hope not. 1, 2, 3, 4. 1, 2, 3, 4, 5. Sometimes when I get to talking here, I kind of lose my track of my mental math stuff. And anyhow, lay a ruler on there. It should be a nice linear line. Linear means straight. It goes all the way through the graph. We need a minimum of 3 points on the graph to draw a line, okay? It's usually kind of the rule, all right? So I'm hoping today that things go pretty quick. Usually we have a table like this, and then you'll see on the other side we'll just make a T-chart instead of a nice big table like this. But we try to pick numbers and start plugging them in. Hopefully you push yourself to do some mental math. -5 plus 4 is -1. -4 plus 4 is 0. -2, that's 2. And 0 plus 4, or yeah, 0 plus 4 is 4. Go graph them. So I'm hoping, again, this is going to be nice and easy too. I'm looking at this graph, and there's really a 1 in front of it, so it better be a positive slope. Going that way. -4, 0. That's kind of usually the biggest mistake kids make in graphing linear lines is they have the wrong slope. So if you predict that before you draw your line, usually you can catch it. And when I'm all done, as you can see that that's a positive slope. And all my dots fall on a nice straight line. Now, there's some kind of error on computers. You can see these guys, but we can make them out. That they wanted us to put a 0 in there, and that's a 4. Now the reason they pick these numbers here, and you're going to start picking them here pretty quick, because when I put a 4 in, I can do this mentally, we hope, because 4, I won't worry about the negative here in a second, 4 times 3 is 12, and 12 divided by 4 is 3. So really, that's a negative times a positive, so that's a negative 3. And a negative 3 and a minus 2 is a minus 5. Now, we still have some kids in here that kind of are still struggling with this whole negative times positive stuff. That's a negative 12, and negative 12 divided, that's a negative 3 minus 3. Minus 2, I see. I was going to say, how did I get 5 down there? But what kind of frustrates us is that at this age we should say, hey, I got some negatives and I got some more negatives. Now I got a bunch of negatives. And some kids still need to put this in the calculator. Start focusing on this so that you don't have to keep putting it in the calculator. I got some negatives and I got some more negatives. I got negative, and so if the signs are the same, we add them to find out how many. 0 is nice and easy. 0 times 3 fourths. Anything times 0 is 0, so that's a minus 2. But look, I put a 4 in because 4 times 3 is 12, and 12 divided by 4 is a positive 3. So now my math problem in my head says 3 minus 2, which is 1. I want to put an 8 in. 8 times 3 is 24, and 24 divided by 4 is 6, and 6 minus 2 is 4. Okay, so our idea of picking these numbers is that they're picking numbers that are easily, when I'm done multiplying, divided by 4. Okay, I would have picked 3. That would have been a lot harder because 3 times 3 is 9, and 9 isn't divisible by 4. So when we get to start to pick our own numbers here, we're going to pick numbers that when I'm done multiplying is easily divisible by 4. So that's what they're trying to teach you. Pick numbers that are easily divisible by whatever that denominator is. Okay, let's go graph this guy. Oh yeah, by the way, positive slope. Even after I told you at the beginning, predict the slope before you graph. Let's see. Now I don't have an 8 for it, and sometimes that happens. There's just nothing you can do. But I have at least 3 lines on my graph, or 3 coordinates. You can't have 3 lines. 3 coordinates on my graph, and so that makes it that I can graph this guy. What happened to my pen? There we go. Use a ruler. Okay, I know Mrs. Tilton kind of provided them for you, or you didn't have them, you just winged it. You're in 10th grade almost. Let's use rulers and let's be precise. Pretty soon we're going to have 2 lines on a graph, and we're going to have to see exactly where they cross, because that's going to be our solution. So let's start right now making them nice and pretty. This also is a positive slope, so when I'm all done, it better be going in an upward fashion. And hopefully you can plug these numbers in. Okay, so it's kind of our goal is to make mental math. Now, -2, -6 isn't on there, but 1, 3 is. Look, 1, 3. I have 0, 0, 1, 3. See, that's what I'm talking about. Oh, I bet this is supposed to be a negative. That one's supposed to be a negative. I can see it kind of hiding underneath there. -1, -3, 1, 2, 3. Because I already have a 1 down here. Alright. So the -1. I don't know why it did that. Did it like on 6 problems today. I fixed it on your worksheet. I caught it in time when I printed it off. You know, it's kind of interesting that some kids, when they draw or put the ruler on their paper, I'm watching my 8th graders, that they put their pencil at a real steep angle and it goes underneath the ruler when they're trying to draw a line. Try to keep it pretty much perpendicular with a slight lean towards you as you're drawing your line. You let the ruler do the guiding of your pencil head there, okay? Let's see what we got here. I got a -2, so this guy probably is a +2, and that's a 0. Alright, so again, they're picking numbers that when I'm done multiplying, first of all, negative times negative is positive. 2 times 3 is 6, but see how 6 is easily divisible by 2, which is 3. So I got positive 3 plus 2. 0 is easy. 2 times 3 is 6, but a positive times a negative is negative. So this is really a negative 6 divided by 2, which is negative 3. And negative 3 plus 2 is negative 1. 4 times 3 is 12, and a positive times negative is a negative, so that's a negative 12 divided by 2. Negative 12 divided by 2 is negative 6 plus 2 is negative 4. Go graph them. There's that 4 that makes it into a 9. So again, I'm hoping that this is nice and quick and easy. Oh yeah, see how this is a negative slope? So my line better be going downwards, and I'm already on a good roll here. 2, negative 1. They better all fall into a nice straight line. So it's just kind of the beginning of, let's make sure we all can graph from domains that they give us on the table. Okay? And that we recognize that's y equals mx plus b is a linear graph there. Okay. Again, negative times negative is a positive, so that becomes positive 3 plus 1. That should be a 4. That's really supposed to be a negative 1, I'm pretty sure. So let's use negative 1. Negative times negative is a positive 1. 1 plus 2. 0 is 1. Negative 4 plus 1 is a minus 3. It's a negative slope, so my line better be going downwards. This is almost too easy of a paper, I'm thinking. Yesterday we had a whole lot of terms and that whole domain range. This guy, they didn't write it in slope-intercept form, but I could very easily by just flipping those guys if I wanted to. Later on when we're graphing, I probably would do that, okay? But right now we're still okay. They're still using numbers that are easily divisible by 3 when I multiply. A negative times a negative is a positive, and x times 1, 3 times 1 is 3. 3 divided by 3 is 1. So really this whole math problem says 1 plus 1, which is 2. Plug in a 0, that's 0. 1 minus 0 is 1. This guy is probably a positive 3. And positive times a negative is a negative. 3 times 1 is 3 divided by 3, so this is 1 minus 1, which is 0. Again, they used a number divisible by 3. Positive times negative is a negative. That's going to be negative 2. 1 take away 2 is a minus 1. Let's go graph it. My slope still should be a negative. Can't do 6 because it's not on the graph, but at least I have 3 points that I can do my line. All the way across, arrows on both ends. Okay? Alright, we're going to start letting you do some of these guys. Oh yeah, now we have domain and range. So what I like to do, because we learned yesterday that domain and range should always be written with the smallest number first, and I don't like to have to keep rewriting things, so what I'll do is I'll make a chart. You see how they have them already, the domain in order from least to greatest, 4, 6, 8? Sometimes it just works out that they're in order over here on the y's, but every once in a while you'll see they're not, so then we have to rearrange them. So again, I'm going to plug in the numbers here. 4 minus 5 is a minus 1. 6 minus 5 is 1. 8 minus 5 is 3. And so it just happened that my range is in order here. So just like yesterday, we need to write the word range. It's in brackets. This is what we call a discrete graph. And they're already in order there, so that worked out really well. Okay. I'm going to put these guys in, so again, it makes it easier. I think this one, you're going to see they're not in order. I'm pretty sure it's this one. So I have a negative 2, so a negative times a negative would be a positive, so that's a minus. It really says 4 minus minus 2, which is a positive. So when I put in 2, negative 2, that becomes a 6. When I put 4 minus 3, that's 1. And 4 minus 5 is a minus 1, so see how they're not in order. So again, do range, and we always put them in order from least to greatest. Negative 1's my smallest, then 1, and then 6. Alright, pause your video and do these guys. And let's see how you did. Okay, we got 4 numbers up there on that one. Alright, let's welcome back and let's see how you did here. There's my answers there. I got negative 2, 1, 4, 13. They were all nicely in order here. And even this one was in order. So a lot of times kids would just plug these numbers in and just put them here. I guess it's kind of a 50-50 shot. But if they're not in order, then you have to rearrange them. So it's up to you if you want to make a T-chart or if you just want to go for it. Okay. Let's see what happens on this one. Hopefully they're picking numbers that's easily divisible by 2. But I know a negative times a negative is a positive, and half of 4 is 2. So now I have 7 plus 2, which is 9. So let's see if it works out here for me. 9. I plug in a 0. 7 minus 0 is 7. So up, see, it's not in order. 6 times, that's a negative. Negative times positive is negative. 6 divided by 2 is 3. So 7 take away 3 is 4. So I want to scratch that out. And I'm going to put range is 4, 7, and 9. Okay, alright, we try this guy real quick. Their numbers are divisible. Now, if you need to use your calculator, go ahead. But try to push yourself a little bit. That negative times a negative is a positive. 12 times 2 is 24. Hopefully we know 24 divided by 3 is. And then add 9 to it. Alright, pause your video and do that one. Should have three ranges over there. Alright, let's see how you did. Yeah, see, they weren't in order, so that's why, again, I like the table here. 17, 13, 7. 7 is 13, 17. Alright, so again, important. Domains and ranges are always in order. You'll see them that way listed here when they give them to you. Alright, now this next paper here is just kind of a review of everything that we've done, keeping our skills up. These guys are all discrete graphs. I can tell because they're individual dots. Okay, so that means my domain is a bracket. And so I'm going to look over here and I want to put them in order. Minus 2, 0, and I see I have 2 3s, but I'm only going to put it once. Range. Close your brackets. Function. I see 2 3s over here. I said I'm only going to list it once. I knew in my head that, boom, that was not a function. Okay, the domain of 3 has 2 y's, or 2 ranges is what I would say if they asked me to explain. Domains here, individual coordinates, looks like they're all in order. Negative 1, 0, 2. Range, they're also in order, so that was nice. And now function, I'm just looking at my x's. Don't see any repeated, so yep, it's a function. Mapping diagram, it looks like they did it right. Minus 7, 0, 3. And over here is my y's. That's also right. It's a 1 and a 2. I'm looking just at this one. I only see one line coming off of each, so that means it's a function. And even though it's going to 2 over here, that's okay. If I map negative 7, 2 on a graph paper over here, negative 7, 2 would be like here. But then 0, 2 would be like right here. So if I did the vertical line test, it's not going to hit each other, even though they both have a 2. They're different on the x-axis, okay? All right, domains, there's a continuous line. So I'm going to have a starting point and a stopping point. So I want to put my x in the middle. You can see on my y, I have a starting point and a stopping point. I know that my arrows always point to the left on compound inequalities if I write the smallest number first. So we learn, take your pencil, start from the left. There's where I hit my graph first at 1, 2, 3, 4. And I stop hitting it at 1. On my y-axis, I start from the pencil from the bottom and start working my way up. I start hitting it at -2. Hit, all the way up to 1, 2, 3 is where I stop hitting it. This is not a function because it doesn't pass the vertical line test. And I think they made a mistake on this one because you don't know right now how to graph a quadratic yet. So let's cross this 2 off, and that makes it a linear line. So a linear line would look something like this. It's a positive one. So it would go like this. So now when I'm doing my domains and ranges, it's a continuous line. So I know it's going to be an x and a y. It goes forever this way and forever that way on the x-axis. Whoops. That means it's all real numbers. So I'm going to get rid of that and say all real numbers. And even on my y, if I start down here with that line, it keeps going down forever in this direction. It keeps going up in that direction. So no matter where I am, I'm going to hit it. So I'm going to get rid of that y and say all real numbers. And now, is it a function? Yep, would pass the vertical line test. Okay, so I'm hoping today is pretty quick and easy for you. Try pushing yourself to do mental math on these guys, okay? Alright, with that, I think you should be good. On these function tables, all you have to do is plug a -3 in, or pick an easy one, like 2. 2 times 2 is 4. No. 4 divided by 3, that's not an easy one. How about 6? Let's put a 6 in. 6 times 2 is 12. 12 divided by 3 is 4. 4 plus 4 is 8. Nope, it ain't that guy. They said there's a -1 when you come out, so A doesn't match with 7. So that's all you kind of do. Let's put a 6 here. 6 minus 7 is a -1, but it's got to work 3 times. If I put a 2 in, 2 minus 7 is a -5. That works. -1 minus 7 is -8, so bam, there it is. A matches up with this guy, so that's what you got to do on those. And we're back to functions and domains and ranges, and whether it's a function. So this will go really, really quick. You'll probably finish it in class today. All right, with that, have a good day. Mm-hmm.